Alright everyone, we're on chapter 6.2, which is solving quadratics by factoring. And a couple things I want you guys to copy down is I want you guys to copy down the directions here, which is to graph this function f of x equals 48x minus 16x squared, and I want you to draw an xy table. I am going to utilize some cool technology here, this program called Algebra. And as you can see, I have this function pumped into the input, and I'm going to hit enter, and that graph shows up. And so you can see its vertex is at this spot, which I know, and I will tell you guys in a second, and it's at this spot, which I will tell you in a second as well. What I really want you guys to focus on is where this graph is crossing the x-axis. And as we can see here, there is crossage here at 0, and there's another cross here at 3. And let's go back to the program here. The vertex of this parabola is at 3 over 2, so 1.5, comma 36. And so what I'm going to do is I'm going to pump in two numbers before, two numbers after. So 1.5, I'm going to go 2 and then 3 and then 1 and then 0. And I'm going to figure out those numbers also. So if I pump in 0 into here, I get 0 times 48, which is 0, minus 16 times 48, which is 0. Now the good thing about a parabola is that from its vertex, it is symmetrical. So if 0 appears two spaces in front, it's going to appear two spaces behind. If I pump in a 1, I get 48 minus 16, which is 32, and it's going to also appear here. Now the piece, again, that I want you guys to pay attention to is the 0, 0, and the 3, 0, because remember, that is where my ground level, or where my graph is hitting ground 0. Alright, that's where it's crossing the x-axis, and that's what we want to pay attention to. Now, I could ask you guys to theoretically go through and graph every single quadratic equation in the chapter, but that's not efficient because this program can draw things efficiently. We're human, we make mistakes. There's actually a much more precise method of solving a quadratic equation, and that is by factoring. So let's go ahead and take a look at how we solve this equation by factoring. If I say 48x minus 16x squared, what I'm going to do is I'm going to set that equal to 0. And what I'm doing is I'm saying, where is this function ground level? And that's all I'm asking. So after setting it equal to 0, I'm going to factor out a 16x. And what I get is 3 minus x on the inside equals 0. Now remember, if I distribute the 16, I'm going to get 48x. If I distribute the 16x, I'm going to get negative 16x squared. So now there's a rule called the zero product property, which says that if two things are being multiplied and they equal 0, then either the left side thing equals 0 or the right side thing equals 0 or both. And so let's go ahead and solve for x both times. If I divide by 16, well, x is going to equal 0. If I add x to both sides, then x equals 3. Well, what do you know? At 3, I have a 0. At 0, I have a 0. And it just so happens that on this graph, at 3, I'm intersecting the x-axis, setting it equal to 0. And at 0, I'm also at ground 0. So that's how all of this stuff is connected, solving by factoring, graphing, and solving by two other methods which we'll learn later on. So what I need you guys to pick up from this lesson is the idea of using factoring to solve a quadratic equation. So let's take a look at some examples here. I don't expect this to be that long. This should be pretty easy. X squared minus 12x plus 27 equals 0. And so I'm going to go and just factor this thing like normal. I'm going to get an x and an x. It's going to be minus minus. Two numbers that multiply to 27 are going to be 3 and 9. They just so happen to sum up to negative 12, which is what they need to do. And then I get x minus 3 equals 0, and x minus 9 equals 0. And for purposes of the quiz, you don't need to show me this step. If you just jump straight to x equals 3 and x equals 9, I will be happy with that. So let's do another one. Example 3. Let's go x squared plus 13x plus 40 equals 0. I'll go through this a little bit faster. I get x plus 8, x plus 5 equals 0, Therefore, x equals negative 8, negative 5. Next example here, let's up it a notch a little bit. Let's go with x squared minus 12x plus 36 equals 0. Well, here I'm going to get x minus 6 times x minus 6 equals 0. So therefore, x only equals 6. Well, let's think about that. If we only have one x-intercept, what that means is that at 6, the parabola is coming down, and then it scoops back up. So it makes contact with the x-axis. We call this a double root. So think of it this way. It has to make impact when it hits the ground, and then it makes impact again when it leaves the ground. All right? Again, you won't be asked to graph any of this stuff. I'm just showing you guys what it looks like. Let's do a couple more examples here before we take off. Let's go with number 4. 3x squared minus 13x equals 10. Well, with any quadratic, you want to make sure you set it equal to 0 if you have any intentions of factoring. So make sure you do that, and now we can factor this thing. So I've got 3x and x. Let's see, two numbers that multiply to 10 are 5 and 2. I'm going to do it in that order, so 5 and 2. Let's take a look if this works. I got a 6, I've got a 5. 6 and 5 can in no way get me to negative 13, so let's see if we can switch the order. If I put a 2 here and a 5 here, I now have 15 and 2, which can somehow get me to negative 13 as long as 15 was negative and 2 was positive. Therefore, x equals negative 2/3 and 5. All they can do really to make it harder would be to change things up visually. 3c squared equals 5c. Again, set it equal to 0. 3c squared minus 5c equals 0. Please make sure you remember your white belt factoring. Factor out a c. 3c minus 5 equals 0. c equals 0. 5 over 3. All right, that's pretty much factoring to solve. We'll see you in the next one.